Welcome back. This is the Tutor Wizard. What we're doing is the definition of derivative. What Sir Isaac Newton is doing in 1666 in the 16 months hiding from the bubonic plague. What did you do during COVID in 2 years? He did the calculus of variation, the spectrum of light, and the first mathematical description of gravity. He wants the instantaneous rate of change of a nonlinear function. So we have some function f in blue. What he wants is the rate of change of this, but what he cleverly knows is for a straight line, a rectilinear line, we have rise over run. Its slope is the rate of change of the vertical over the rate of change of the horizontal. So he takes a secant line, sec RA is to cut the curve, so the secant line has a slope, which in calculus we call the average rate of change in an interval. So if I have an interval a to a plus h, the average rate of change is the slope of the secant line, the change in y over the change in x. What Newton cleverly does is he pushes h to 0, so he says in that interval make it start at a, I want to know what the instantaneous rate of change at a is. So he moves out a little bit, h is some small number, he makes h go to 0, so this point will move to this point. And so what's going to happen to the secant lines is it will eventually coincide to where it touches, and we have a tangent line. Tangent is to touch the curve. And so now what that says is the instantaneous rate of change of the red function, which is a rectilinear function, is the same instantaneous rate of change of the nonlinear function, and they coincide there. So what he's saying is he's taking the limit of the secant lines and putting all that terminology and notation together, we get to the definition of derivative is the limit. This is where we have to pass for thousands of years. We pass to the limit finally, and we get to the limit as h approaches 0 of f of a plus h minus f of a over h. And then we get the slope of the tangent line. The equation of the tangent line involves the slope right there, but this is the equation of a line which happens to be tangent. We also have an alternate definition of derivative where if we put x equal a plus h, we get this alternate definition. If you want to see which one's better and why, watch the next video.